Here is an interesting function. F of x is signum function of x minus x if that value signum function of x minus x is a positive number and it is 0 if otherwise. Then four different statements regarding f of x are given and we need to identify which of them is false. Now before we proceed to verify each of these cases, first let us try to identify how will be the function f of x. Now on the axis, if we consider the graph of signum function of x, it will be when x is positive, it will be a line 1, that is y equal to 1, and when x is negative, it will be y equal to minus 1. So as we know, signum function of x is clearly 1 if x is positive, and it will be 0 if x is 0, and it is minus 1 if x is less than 0. So at 1 and minus 1, this will be a line parallel to x-axis. Now how will be the second graph, y equal to x? Yes, that would be a line passing through our region. Now if you look at this region, what do we need? We are given that f of x is the value of signum function of x minus x if signum function of x is greater than that of x and it is 0 if otherwise. Now from the graph you can clearly see signum function of x is greater than x only between 0 to 1 and from minus infinity to 1. So what do we observe here? These are the regions where signum function of x is greater than x. These shaded regions are the values where the function is more than that of 0. So can we rewrite this function f of x defined piecewise as it would be minus 1 minus x if x is less than or equal to minus 1, and it would be 0 if x lies between minus 1 and 0, isn't it? Between these two, because signum function of x minus x is a negative number, therefore it would fall under this category, and it would be 1 minus x if x lies between 0 and 1, and it is again 0 because between 0 and 1 if you observe, signum function is more than that of x values, and it will be 0 if x is greater than 1. After 1 it would be 0 because signum function of x minus x would become negative now as x is more than that of signum x. Then for this function y equal to f of x, how will be the graph of the function? Yes, below minus 1 it's the line y equal to minus 1 minus x. So if we plan the graph, it would be along this line up to minus 1, and after minus 1 it would be 0, but again from between 0 to 1 it would be the line y equal to 1 minus x, and after 1 the graph would be along 0 line. So this green shaded region would give us the graph of y equal to f of x. Now let's analyze what are the regions required. As we have just now identified, this region is the required region. So for the value of x to be more than or equal to 1, first let us verify what is integral minus 2 to x f of x dx. So which region is required? From minus 2 to x, where x is a number which is more than 1. Then can we write this as integral minus 2 to minus 1 f of x dx plus integral minus 1 to 0 f of x dx. We are splitting where the function is changing its character. Then again from 0 to 1 f of x dx, and as x is more than 1, then it is from 1 to x f of x dx. But clearly if you can see, between minus 1 and 0 this function is 0, so this integral becomes 0, and 1 to x this function is also 0, so this is also takes a value 0. So what is left out now? This is integral minus 2 to minus 1 f of x dx plus integral 0 to 1 f of x dx, and we have the function at both the cases. So can we calculate this area? Yes. How much it will be? From minus 2 to minus 1. What is f of x between minus 2 and minus 1? It is minus 1 minus x dx plus integral 0 to 1. Between 0 to 1 it is the graph of y equal to 1 minus x. So it is integral of 1 minus x dx, which comes to 1 square unit. So if you look at the options given, at A, integral minus 2 to x f of x dx is a constant for all x greater than A. Therefore, from our observation, A is clearly true statement. Not only this, the second statement is also true, because what we calculated, minus 2 to x f of dx is coming to be 1 square unit for x is greater than 1, right? So shall we also conclude that even statement B is also true? Now among C and D, we need to pick which one is false. So let's again go to the diagram of the graph of y equal to f of x. When we try to evaluate integral minus n to x f of x dx. Now these are two triangular regions from x equal to minus n to x equal to a number which is more than 1, right? That means this would be half times the area of the triangle found on the left side of y-axis. That would be half times the base length is from minus 1 to minus 1 minus n. So that would be n minus 1 units, and the height will also be equal to n minus 1 units, plus there is also another portion between minus 1 and 0, the area is 0. Beyond 1, the area is 0. But from minus n to x, there is another portion between this that would give us half times base length is 1 and the height is also 1. So this would be half times n minus 1 whole square plus 1 square units. So integral minus n to x f of dx is coming up to be half times n minus 1 whole square plus 1. So if you observe the choices given, even the D option which says integral minus n to x f of x dx equal to half times n minus 1 whole square plus 1, where x is more than 1 and n is a natural number, is also true. So shall we conclude even D is observed to be true, right? We can stop calculating it by saying that now C should be false. But let us even see that from the diagram of f of x. If you can see here, the area from minus 1 to plus 1, this total area will be same as integral from 0 to 1, because from minus 1 to 1, the area is 0. Now when we wanted to calculate integral minus 1 to 1 f of x dx, and when we split this into two parts as minus 1 to 0 f of x dx plus integral 0 to 1 f of x dx, as between minus 1 and 0 f of x is a 0 function, so this is 0, and the rest is integral 0 to 1 f of x dx. But if you look at the C choice given to us, integral minus 1 to 1 f of x dx is given to be twice that of 0 to 1 f of x, but it is only equal to 0 to 1 integral 0 to 1 f of x dx, no 2. So we can conclude that C is actually a false statement, right? So we need to select the false statement. So which is false? The option present at C is a false option.